Hey, welcome back to the channel. Good to see you again. Thanks for joining. Hope you're all well. Today I got on the bench Sound Dynamics, another plate amplifier. This one here is THS-15. I don't know anything about these plate amplifiers other than they're just a basic amplifier, and then they have signal conditioning and filters and whatnot. But this one's a little different from the other one I just did. This one doesn't have a switching power supply. It has a linear transformer, kind of a beefy transformer. I'd say it's good for maybe 100 watts. I'm not sure. It has 100 written on the transformer. So this is the way I got it. It was kind of half disassembled, some pieces in a bag, and this is, might as well just remove this. This is kind of flopping in the wind here. I'll get it later. There's a nut in the back. But anyways, this came in a lot of other stuff that was brought to me from a client. He says, fix it, please. And I said, sure. Okay, so this one was made in Canada. And it's a lot higher build quality than the one I had done that was made in China. It's aluminum plate. It has a heat sink under here, you can see. This is just good. And it's got a protective cover on it. I don't understand why it would have a protective cover. It shouldn't get that hot. On the back side, we have traditional transformer power supply, filter caps, bridge rectifier, and then it looks like there's 4 devices here that look like power transistors, output transistors. I don't know. I don't know what kind of a circuit. It looks like it's just a traditional power amplifier. It looks like it's in bridge mode. You've got 4 transistors on each side, or 2 transistors on each side. So it looks like maybe they're using a bridged amplifier here for maximum output. But he says it doesn't work. Please help. Oh, look at this. They even ground off the numbers off these chips, so you can't duplicate that. That's probably some proprietary work there. Audio Products International Corp. Audio Products International. Sound Dynamics. Okay. So I was looking this over. Got a power supply here. These 2 black wires up top are the primary. And it goes through a fuse, which is missing. And it goes to the power cord through a thermal switch. This is a thermal cutout. So I guess if it gets too hot, it's going to shut down, which is fine. But there's no hard power switch on this thing. None. So when you plug it in, it's live all the time. I don't much like those kind of designs. But then on the other hand, I think a lot of people that use subwoofers and these plate amps, they just plug them in and forget about them, and they leave them on all the time. I think that's the reason why a lot of the ones I've looked at recently have cooked capacitors in them, because they're just powered on indefinitely and they never shut them off. And they're always there, used or not. It's not always powered on, used or not. So, you got, yeah, it's a simple circuit. Switch, fuse, transformer, that's all there is. There's no grounding. I was looking at the secondary here though. Center tap secondary. The red wire is a center tap, I'm assuming, CT on the board here. And then 2 white wires. This one was disconnected. I don't know why. Maybe that's our fault right there. That would be easy. So what we could do, we could put a fuse in. It says a 1.25 amp. And we could reattach this secondary winding, plug it in, and see what it does. It has 2 spade lugs here for the output to the speaker. We can do that. It has a power light, power LED. Let's take this off first. Okay, let's zoom you in. Okay, one thing I want to do before I power it up is I want to check the output devices for shorts. And there's 4 transistors here, so let's check these. Not shorted. Yeah, that one's buggered. I don't know what they're using for outputs. So they buy That's shorted too. Huh. Shorted. I don't, like I said, I don't know what they're using for output devices. They could be MOSFETs, or they could be bipolar. Looks like everything's shorted here. What is going on? Okay, well, let's take the board off the plate and we'll have a good look at this. Okay, that was quick and painless. A few screws and out it comes. I had to desolder the pilot lamp LEDs, that's the only thing, so it's pretty easy. Okay, let's check these devices again, because now that I took it out and I can see the part numbers, they are definitely MOSFETs. They are IRF 640, all 4 of them, and so that would be gate drain source, or gate source drain. I can't remember which one it is. It doesn't really matter anyways. I'm going to check between the drain and the source, and dead short. Well, no, we got, why do we have 9/10 of an ohm? Dead short? No. One ohm here. 4. They're not behaving like dead shorts. They're behaving like they're turned on. That's weird. I wonder if I can... 5/9. Try this again. Yeah, I don't know. I think these MOSFETs have had it. I could take them out and test them, but I don't think I'm going to get any different results here. It just seems like they're conducting. This one here has a gate resistance of 190 ohms. This one has a gate resistance of 2 ohms. Okay, let's try a diode checker. Maybe that's why I'm not... Okay. Yeah, that's a dead short. And that's a dead short between the gate. This one on the gate, you got a little bit of life there, but it's not enough. Yeah, they're dead shorted. Dead shorted. Okay, so I'm going to have to check my inventory, see if I have any IRF 640s. Probably what I'll have to do is pull the data sheet on these and match something up that's going to be equal to or better than. So then we have a matched set of 4. Everything else on the board looks fine. I should text this TIP33 while I'm here. I don't know what this transistor does, but seems fine. It's not shorted. Okay. And then I'll have to check some of these caps too. They don't look bad. And they're quality caps. They're Rubicons. The blue ones are Rubicons. And the black ones are Jamicon. Alright, so I found 5 new MOSFETs in stock. And I'm lucky that way. So we'll put those in. Got to remove the old ones. They have... On 2 of the MOSFETs, they have these just regular silicon diodes on here. These are just IN4814, or what are they? I can't even read it. 1448? Is that what they are? But anyways, they're just regular silicon diodes. And they're glued. They're with an adhesive to the transistor. and to you can't really peel it off without destroying the diode. So my solution is, here I'll just take a little bit of aluminum extrusion for heat. Now, get a pair of tweezers ready, and just hit it with a torch. Get these wires out of the way. And hit it good and hot on the back of the transistor. And before you know it, it'll be out. So just take this off. Just pull the transistor out. So what I'll do now is I'll clean the holes. I'll clean all 12 holes, and then I'll put the new transistors in, and then I'll mount this on the plate again before I solder it, just so that they're in the line. A few other things you need to be aware of. Before you put in new silicon here, you want to go with your diode checker and check all these diodes and transistors. Make sure that none of them got bloated up from any back currents or back voltages that fed back from these shorting out. Especially these two little diodes here, that you want to make sure that they're good. And it'd also be a good idea to go through and check all these resistors, because some of these are low value, like 100 ohm, and even though they might not look burnt, they might be open. So go through and check them. I checked all these and I didn't find any bad components here, so everything's good. I even went as far as to check all the capacitors all throughout, and they're all testing fine, so I'm just going to leave it alone. I'm just going to put 4 new MOSFETs in here and secure it all down and try it. Now, what I want to do is I want to mount this back on the plate, because what my objective is to mount it on the plate with the hardware, and what that does is it locates the transistors in their proper position, and then I'll solder them. I'll solder all the legs, and then after that I can remove it. I still have to go through and glue these diodes down onto the transistors, and I'll do that after I solder it, so that nothing moves around. So I'll do that now. I'll just put this on. Get my fat fingers out of the way, and that should be good. And I'll secure this on. Don't give you much room to work. Probably be better if I took the transformer off, but I'm not going to do that. Anyways, I'll fight with this off camera and then I'll come back. One last step before we call her done is we have to glue the diodes to the transistors. And this is what I'm going to use. It's a thermal epoxy. So let's try this out. I don't know what they put in here. Maybe it's silver powder in it, zinc oxide. Let's see what it contains. Zinc oxide, phenol, polymer with formaldehyde, glycol ether, carbon black. Carbon black. There's no mention of any silver. Zinc oxide. Yeah, so we just need a little bit here. Let's put some here. And a little dab will do you here. And then we can just push these diodes into place, and they'll stay there, and they'll be bonded and coupled. Okay, now I can reassemble this. Why not? I got extra. I'll never get those diodes out. This is epoxy, so. Actually, no, that's not true. If I took a torch and heated it like I did when I removed it, that epoxy will let go. So I'll throw this away. Now, Everything's done. Just need to find a fuse, put it back on the plate, reconnect the LED and the transformer, and away we go. Okay, we're all back together now. I got it assembled, put a new fuse in. Everything looks good. There's no power switch on this thing, which is kind of bewildering. I wish they put power switches on these. Like, how much more would it cost them to do that? Anyways, I made up a couple of special leads here with spade connectors on the ends, and an alligator clips, gator clips, not croc clips. Depending what part of the planet you live on, you guys got to be gator clips. So yeah, we got it into a load, and I got it plugged into my isolation transformer. So let's turn it on, and hopefully we won't get any smoke. Shouldn't. Everything looks pretty good. So let's turn this on. And no pop fuses. Good. Let's turn on a signal. We have an LED at least. Let's look here. Yes. No, we don't have any LED. What turns on the LED? Do we gotta feed it a signal? Let's feed it a signal then. No LED. I don't know how we switch this thing on. Let's see what we have for power supply. On our caps we have 55 volts. 55 volts. So it's powered up. It just needs to be woken up. I don't know how to do that. Let me look at this thing for a while and figure this out. Feeding in a signal. Let's turn up the volume. Interesting. Okay, let me look at this. I don't know what turns it on, but it doesn't look like it's playing nice right now. I'm wondering if there's a connector or something that's missing. I know something's been removed here, and somebody's been desoldering something on the board, and this is your high level input, in and out, but that's just a pass-through signal. And then they have the same pass-through thing here for the low level as well, but there's no inkling of how this thing switches on. I guess it should be sensing a signal, but it's not. So let me look more into this. Alright, so maybe I'm losing my mind here, but stranger things have happened. I was checking some of these chips, these TL084s, op amps. They're all over the place. I was checking to make sure that they all had power supplies, and they all had plus minus 12 volts, plus minus. I was checking, and then I checked this LM358 here, a little op amp, and I looked over, I noticed the LED was on, and I'm, what the hell's going on? So I think it has maybe a power on delay. I'm not sure. So let's try this again. Turn it on, and the LED is off, and I think if I wait long enough, it comes on. like right now. So I think the amp's active. Okay, I'll get it wired in for the power test again, and then give me a chance to set up the second camera and we'll do that. Alright, so it's all wired in, it's powered up. See if our LED comes back on. And I'm feeding it a 100 millivolt signal, so we should see something on the scope. Okay, so that's lit. Our volume is turned up now. I don't see anything on the scope. Okay. Oh, maybe we got a bad connection here. That's odd. Okay, well, I'll start feeding it a signal. I'm getting nothing through this. I'm on channel 1. There we go. We got a bad connector here on the input. Okay, excuse the interruption there. Yeah, this is not behaving properly. Amp is on, and I'll show you when I connect an input signal ungrounded. I just connect the center pin. The signal comes up and it stays there. When I ground the outer conductor of this, it goes dead. I don't understand what is going on with this. The amplifier is working. Because when I do this and I check the output level, we're getting 23.85 volts RMS output, and that's probably the max. That's into an 8 ohm load. .8 volts. It is working. The amplifier is working. There's something messed up with the input. And I do have my signal on. Let me connect another signal here. How much signal do I need to drive into this? That is 100 hertz. And that is exactly what I'm feeding in, 100 hertz. Let's try a different frequency. It's responding to the signal generator. I just don't understand this ground thing. I don't know what to make of this. Let me check the, let me turn this off, and I'm going to check the, it's getting a little bit warm. Check the signal coming out of this cable. This cable should have no problem. And there it is. That's the signal coming out of the cable going into the amplifier. So I don't understand the unless this is odd. Let me think about this. Okay, very interesting circuit here. Doesn't matter what input signal I feed into it, what amplitude. It always regulates and keeps the output the exact same. So here I'll show you. I can turn on this level, turn up the level, full volume, getting 23.75 volts on the output on an 8 ohm load. And I can adjust the amplitude on my signal generator here. I can turn it right up, turn it right down, and it makes no difference on the scope what's coming out. It's regulated and leveled, and then this level control controls the amplitude. But this is for a subwoofer, so that's interesting, because how would you control the amount of bass coming out of your program material depending on how loud it is? This doesn't make sense to me. It's one constant level depending on this knob setting, and I just still can't get over what's going on with this. If I plug in the RCA jack all the way, my signal goes flatline and disappears, and no matter how I adjust this level control, it doesn't come back. So yeah, I don't know what it's sensing there. Is it a low impedance it's sensing, or is it I just don't get this. So it appears to be working. It appears to be putting on full power, but I'm not sure how it works with regards to connecting up to the stereo. So do I give it back to the customer and say, yeah, it's working, or do I say, ooh, something really weird's going on with it? I want to check the input circuits here to make sure everything's okay. It's a mono amplifier. Yeah, this is, see, I don't know anything about these plate amplifiers. Absolutely nothing. It's just all chips and capacitors and resistors to me, so I don't know how it's supposed to behave. That's the thing. So I think it's done, but it's not behaving how I'd expect it to behave. So I guess I'll give it back to him, and you'll have to reinstall it back in the cabinet. I don't know what's going on with this that was removed. Somebody removed something from the board here. There's solder pads that are empty, and it looks like somebody removed something, and the connectors are missing. So yeah, I don't know what is going on with this. All right, I guess it was a repair. It's putting out power. This is getting warm. So it's interesting though. Never seen this before. Full power. And when you connect the signal, it ramps up. You can see how it ramps up, like it's automatically leveled. I'll do it from here, just from the beginning. Connected. Actually, I'm driving a 2.1 volt signal in. Let's turn this down. Turn it down to 200 millivolts. So here we go, connecting it. And then it just automatically ramps up to full power, depending on this knob setting. It's got a mind of its own. Anyways, that's it for this one. I'm going to give the owner a call and let him know what's going on with this thing. But thanks for watching, and take care. See you on the next one.